Children, let us see some more trigonometrical questions to be solved. In the previous video we had solved 2. Let us see some more. What is given here? Sec to the power 4a bracket 1 minus sin to the power 4a minus 2 tan to the power 2a is equal to 1. We have to prove this. We have to prove that the left hand side is equal to the right hand side. So let us take the left hand side. Sec to the power 4a 1 minus sin to the power 4a minus 2 tan square a. Fine. Now here children, let us do some changes. What the changes has to be done is, when you see 1 minus sin to the power 4a, can it be written as 1 the 4 minus sin a to the power 4 minus 2 tan square a. Fine. Now again sec can be converted to cos as 1 upon cos 4a, as we know sec a is equal to 1 upon cos a. Therefore sec 4a is 1 upon cos 4a, and this can be written as 1 the square minus sin square a the square. Yes children, can it be written in that manner? So we get it as a square minus b square. Fine. A square minus b square is nothing but an algebraic identity as a minus b and a plus b. So we will get it as a square minus b square, a plus b and a minus b. In place of a we have 1, and in place of b we have 1 the square is nothing but 1 only. Either you can write 1 the square, that doesn't make any difference, sin square a, and 1 minus sin square a. Fine. And here the tan can be written as, we have the trigonometrical identity sec square a minus 1 is equal to tan square a. So that has to be replaced. Fine. Now cos 4a as it is, the inside one let us see 1 plus sin square a and 1 minus sin square a, where again 1 minus sin square a gives us nothing but cos square a, and here let us open the bracket children. Minus 2 into sec square a is minus 2 sec square a, minus and minus plus 2. Now this can be written as cos square a. So 1 upon cos 4a, open the brackets, 1 plus sin square a, and 1 minus sin square a can be written as cos square a, and again the sec can be written as 1 upon cos. So sec square a is nothing but 1 upon cos, as we had here. Where did you get cos square a? We got it from the trigonometrical identity 1 minus sin square a is equal to cos square a. Too many things has to be applied children. You have to keep in your mind too many things. Now cos square a and cos 4a, if we cancel, we are left with 1 upon cos square a, 1 plus sin square a, and minus 2 upon cos square a plus 2. Now let us add all these things children. These two have the common denominator cos square a, so let us have as 1 denominator, and the above one in the numerator will be as they are, minus 2 plus 2. Now this 1 minus 2 is nothing but minus 1 plus sin square a upon cos square a plus 2, 1 minus 1 plus sin square a, rewrite it as sin square a minus 1 upon cos square a plus 2, and if you take minus common here, you will get it as 1 minus sin square a upon cos square a plus 2, which can be written as minus 1 minus sin square a is nothing but cos square a. Already we know the trigonometrical identity. Hence we get minus 1 plus 2, that is equal to 1, and is the RHS. Hence LHS is equal to the right hand side, which we were needed to. Let us see another question, children, in this segment. What is given to us? Given to us is tan theta upon sec theta minus 1 is equal to tan theta plus sec theta plus 1 upon tan theta plus sec theta minus 1. We have to prove the left hand side is equal to the right hand side. Alright, so let us see how it is done. In this, we have to take the trigonometrical identity. Sec square theta minus 1 is equal to tan square theta. So this, what we have taken is a trigonometrical identity, and the left hand side shows the algebraic identity as a square minus b square, and we can split tan square theta into tan theta. A square minus b square is equal to a plus b, and a minus b we can take the left hand side and split the right hand side as tan theta into tan theta, which makes us tan square theta. So a square minus b square will give you a minus b and a plus b. So the right hand side as it is. Fine. Now bring one tan theta to the left, and right side we have already left with 1. Take the sec theta minus 1 to the right hand side. Now we have learnt about the theorems of equal ratios. So what does it give us by the theorems of equal ratios? What we can do is, each ratio can be equal to, we can add the numerator to the numerator and denominator to the denominator. Even it can be subtracted, and how we need, according to our need, we will take it, because we have all positives here, additions here, so we are adding up. And tan theta plus sec theta minus 1. If you see sec theta plus 1 plus tan theta upon tan theta plus sec theta minus 1. So that's why we added by the theorems of equal ratios. The numerator plus the numerator upon the denominator plus the denominator will be equal to each ratio. Which ratios? What you got as a ratio will be equal to either sec theta plus 1 upon tan theta, even also it will be equal to tan theta upon sec theta minus 1. So we will be taking according to our need. We want the second one, hence we can write the final answer as tan theta upon sec theta, because we have written each ratio, means among these two ratios this is also equal to the what we have got, even the second one will be equal to what we have got, equal to, you can rearrange it as we want, tan theta plus sec theta plus 1 upon tan theta plus sec theta minus 1. Hence